Yeah. Good morning, guys. Nitin. Last. Yeah. Today we have a hackathon on vehicle sales. Okay, vehicle sales in United Arab Emirates. Fine. Um, this project on data science. Okay, we have things on data analytics and things on data science. Two things we have here. So who are completed data science, those guys can complete full project. And who are with data analytics, up to visualization part, you can do. Okay, so data loading and data manipulation and data visualization, those things you can do here. Fine. Yeah. So if you have any queries or any things regarding this data analytics or data science or real world problem statements and how they are solving their problems, all those things you can ask him. And he is Mr. Sunil, and he have a total 7 years of experience in data science industry. Okay, and he will continue the session now. Right now, sir. He light now. He light of this. డేటా ఎక్కడ ఓపెన్ చేశారు డేటా ఎక్కడ ఓపెన్ చేశారు సార్ డేటా ఓపెన్ చేయండి ఐడిలో గుడ్ మార్నింగ్ గుడ్ మార్నింగ్ everyone. Yeah. You all have the data set, right? No? Yes, yes. So have you gone through the data? Like, I mean, do you have any, have you gone through the data and understood anything from the data? Nothing. Haven't seen the data. So before we start, my name is Sunil. So I'm working as a data scientist, and I come up with around total of 7 years experience, and working in different industries like specialty chemicals and life sciences, pharmaceuticals, and then energy services. So I have been working in these industries. Currently, I'm working with one of the reputed product based organization as a data scientist. So my daily workload will be like we have data in different locations, like in different databases, and getting the data and then using them to try to train or build some models, come up with some solutions which the particular, like I mean, which the particular stakeholder is facing, and we try to provide solutions for them. So that's our major role on day-to-day basis. So I hope you guys are all here to become data analysts or data scientists or anyone into data engineering, everyone into data analysts. I will get an answer. Then, are you guys all into data analyst, or you plan to become a data scientist, or you plan to become a data engineer? Online students. Everyone are data analysts. Yeah, I'm data scientist. And the border between all these fields is very marginal, and you can't expect. I mean, like you can't expect that I'm a data analyst, so I just need to
analyze the data when which a data engineer used to be. But in real life scenario, what might happen is depending upon the organization, you might need to do some data engineering activities as well. You might think like data engineering is something which will deal with AI flows or different tools which they will be like PySpark or different tools which they will be using on day-to-day basis. But it's not like you have to use that particular tool. Depending on your requirement, you need to work on different tools. Like for example, let's say that you are in an industry and they are maintaining the data warehouse in some tool, and then they are using some SQL based database in order to provide the data to you. Then what they tell you is like the data is here and you have access to get the go and look the data. But again, it depends on how you deal with the data and how you get the data into the platform which you are working. Like for example, you might be working on Power BI, or you might be working on Tableau, or you might be working in Python as well. But it depends on you how you are going to connect that database with your tool, with the tool which you are going to use. So that's what you need to understand first thing. First thing is like understanding how to connect with the interface which we are where you are working and the database where the data stays, and then connecting these two simultaneously. When you make some operations in the tool which you are using for analysis, you need to push that. I mean, like for example, when you work on data, you might be creating new features. You might be creating new tables from the analysis which you are doing. So you need to push that one so that the stakeholder who is the final user of this analysis which you are providing will be having access to this information as well. That means you need to perform some actions on your data and then push that uh, resultant data tables or resultant information to the database where everyone can access that information. If I'm going fast, let me know, because I speak with fast. So let me know if you are not comfortable with that pace, so that I can tone down a bit. Okay. So I hope everything is clear. I mean, everyone are able to understand and follow what I'm trying to do. Right. So do you have any questions so far? No. Okay. So that's one thing. Before entering, going to the industry or getting into a job, what you need to understand is you need to understand the databases and you need to understand the interface which you are going to work with. For example, I think you are working with Power BI. And please note that by default, when you are in data field, majority of them will expect that you know Python and you know SQL. So their expectation is that by default, you know them. When I say Python, I don't say that you need to have object-oriented programming. But if you know object-oriented programming, that's much better and it will be easy for you to enter into this field. And so Python and SQL are compulsory because majority of the information or majority of data will be in the databases, and you need to do actions on top of that data by taking that data, by querying the data, because the data will not be like in a single CSV file or in a single data table which will you be seeing everywhere. It will be in different tables and different views, and you need to connect to that particular view and then connect to that particular table and extract that information. Sometimes you need to join multiple tables and then use that information for your analysis. Or sometimes you need to come up with a calculated table and use that information. When I say SQL, you need to be good at SQL for sure. Because it's not like I can write a select statement and I can write a join statement and then I will be okay with what I'm doing. But what they expect is that you need to have Windows functions, rank functions, and you need to know proper joining methods, and you need to know CTE expressions. So you need to do all these things, and it's not that tough to understand these functions. If you go through them, it will be easy for you. It's just practice, and there are a lot of options for you to practice, utilize them, and learn SQL as much as possible. Because whether you are data analyst, or data scientist, or data engineer, or a data developer, SQL will be used by at least 80% of companies, either it's in cloud or it's in their own database. So finally, someday or other day, you need to have, you will be using SQL. So be strong with SQL. And the second important thing you need to get strong is Python. Be good at Python, because when you are good at Python, it will be easy for you to enter into either of these three fields. So that's another thing. And my recommendation to anyone who want to start career in data field is like, don't just focus on what you want to be only. Like for example, if you want to become data analyst, don't just focus on the analytics part. Focus on collecting the data and delivering the result. So you need to have you need to have an idea, at least an idea about how the data is being collected and how the data transformation is being done, and then how this transformed data is being used, and then your analytics part comes in. And then after completing the analytics part, you need to come up with some model or something if possible, and use that model and try to containerize the model and deploy the model so that you need to have an idea, because while clearing the interview, you need to know all this information. But when you clear the interview, it depends on the work you have over there. So it's not like you need to do end to end. Sometimes you might need, even in data analytics part, you need to do only one part of that job in most of the time. But you need to know to enter into that organization, you need to know all this information. So focus on all this and try to increase your width as well along with the depth in analytics space. So, and you all know, like with the developments in AI, like are you aware of LLMs and ChatGPT, Llama, and all these advancements that are happening? So with these advancements, you need to be more you need to be more aware with what is going on in the industry, and you need to understand what is the new thing that can be expected, and what is something where I can add value to the organization. So it's not like if I just focus on, I mean, it's a harsh truth that if you go into an industry just knowing only I will focus on this particular analytics part, someday or other day you will become obsolete, and you might not be that useful for the organization. So it might be difficult for you to find a job. So better you need to have width as well along with the depth. So understand different nuances of data industry so that it will be in advantageous position, so that you will always be you'll always be like in a role or in job in a company. So this is my recommendation and this is my suggestion. So try to add some width as well along with depth. Are you all freshers? I mean, like coming directly out of college, or are you guys having some work experience and then coming into this field? Okay. Okay. How many of you are having some work experience in IT industry? No one. What is the background? What is your background? Don't mind. Okay. Marketing. What about you?
MBA.
HR.
MBA finance.
Finance. So you worked in a finance.
No, in non-IT. I'm working in non-IT.
You're working
In non-IT.
non-IT only. So what is you are working in a company?
Yes.
In finance department.
No, Google.
Google Maps. Okay. Claims facility, insurance company. So for you, 1, 2, 3, 4, 5 guys, there is an advantage and there is a disadvantage for you. So you are from claims associate, right? The advantage for you will be like you already know what is different concepts related to insurance industry, and when you apply analytics, you can use even your knowledge related to that one to analyze this industry effectively. But because you know, like for example, if you want to, if you're analyzing and like we have an use case, so I mean, this will be applicable for everyone. So the use case was that we have different this and B2B business. So the company is an US insurance company. So they provide the insurance to business segments. So we have different information about the particular customer which which they are going to sell their products for. So that different information itself, like the demographic information, the business profile information, about the information about the decision maker, at the same time how this person initially approached him and what was his response, and how fast was the response, and how duration was the call. So all this information was there. I mean, if the communication was through email, what was the response? What was the delay in response? So there are different problems with us, and we need to build an algorithm which will predict what is the probability that given this particular profile of an customer, what is the probability that this particular customer will turn into business. So this is the problem statement. So to deal this one, we had around 200 to 2000 columns with us. But using 200 to 3000 columns will not be an ideal case in any kind of industry or in any kind of problem statement. So first we need to do some EDA in order to identify which features will contribute more, right? So for example, what do you think? If I give you a column, I mean, you are working in that industry, right? So just you have some idea about that one. So if I say that the customer was approaching through, I mean, he was approaching through a call, and when we call, he picked up the call immediately within 3 seconds, and he spoke to us for around 10 minutes. So this one profile, I'm telling you just one data point. So another data point is like the customer didn't pick the call in the first attempt and didn't pick the call in the second attempt and pick the call in third attempt, but he spoke only for 10 seconds and then he disconnected the call. So what do you think this feature tells us? This feature tells us the interest of the particular client, right? Because we know that if a person is spending more than 10 minutes to understand the product, the chance of that particular customer turning into business is comparatively high. Because when we also know that when we receive a call from bank or financial company, like they will be calling you, we have personal loan, we have that account, we have credit card, we immediately disconnect that one. If we are interested, if you observe, if we have some need, if we have some need that we want to have a credit card and none of the banks are offering that credit card to us because of our package or because we don't have a 3 months pay slip or because of any other reason, because of CIBIL score or anything, we will be more interested to know and get that particular credit card. But if we have been receiving all these calls and we already have a credit card and we already use that one and we don't want to use any credit card, we don't try to even continue further discussion. We just say like we are not interested and disconnect the card. So this is how you need to approach the business problem. Like this is how we try to approach and we try to come up with different bins where we can collect the information of multiple columns and then create a single column out of 10 to 20 columns so that this information from these 20 columns can be fixed into one single column so that this 2000 columns will be reduced to 200 columns. Then the analysis will be easy and the information which we can extract will be more easy. And then the model which we are going to train will be better because when compared to having 2000 columns, and like for example, let's take there are 15 columns for age, like 0 to 10, 0 to 10, 20 to 30, 30 to 40, 40 to 50, 50 to 60. Like I mean, they have been entering age columns like this, but we don't need that many bins for that one, that many columns for that one. Instead of that one, what we can do is that we can create an age column and we can drop the age column into that one and we can encode that information into different categories like younger, adult, older, like this, so that we are using that information, but we are reducing the number of columns. Similarly, the way we approach the first email response, second email response, third email follow-up, all this information can be clubbed into information which can tell us like, okay, this is the third follow-up. He has to use follow-up, even no response after follow-up. So we can congest, we can congest that information into one feature itself so that that information will not be lost anywhere, but can be used by, but can have all the necessary information that is available in all these columns. So this is one of the problem statement which we had to deal with from insurance industry. So this is how the data will be reviewed. So you'll be having a lot of what do you call irregularities in data and a lot of null values, lot of nans, lot of information which doesn't even make a sense within that because that data will be entered manually by some person by aiding from some other person. He might be an hurry, so he might enter something within that information. So most of the data which you might get before pre-processing, or if a data engineer is not there, like for example, if you are a startup where you are dealing entire process. So what happens is like most of the in some cases there might not be a data engineer who will be dealing with this processing of data, and you need to deal with the raw data, which will be always most of the time. I don't say always, but most of the times the data will be like it doesn't make any sense to you. And even by looking at the data, you can't even think of analyzing that. So that will be the position of data when you deal with raw data. So you need to have some patience for sure, because without patience, you can't deal with that data. And you need to have an idea like what kind of transformations can I apply on this data so that I will be ready for me to do the further analysis. So you need to start with that step and then enter into this step. And once you have data, first thing is like go through each and every aspect of the data, try to write your questions and get that questions answered. Never assume anything. No, you should never have any assumptions, and if you all, even though if you have assumptions, frame that assumptions into questions and get that answered from the business stakeholder, because he will be the right one to answer and he is supposed to answer the question. Because if you assume something and if you have an assumption with you and your assumption might be right, but they won't. Sometimes what happens is like you are data analyst, you know how to deal with data, but you don't know the business segment. Yes. So they know what they want. They might be expecting something which you that see, for example, what happens is like the business stakeholder might be expecting something from the data, Like he expects like this is I've been in industry so many years, so I know what happens with this one. So if this is the case, this will be the result, and this is what result they will come up with. That's what they expect. But in real time, what happens is like data always will surprise you. It will they give you something which no one expects. So that's how powerful this data is. And you might come up, you might have an assumption which is correct, but you might give this output to the client, and he'll say you that he will tell you that okay, this is not right. This assumption is incorrect. So because you didn't approach fully, when you need to restart this one, and your deadline will be missed. So whenever you enter into an organization, whenever you are working on a project, always first go through the data, understand the data, try to have a clear look about the data, and then raise your questions. Always, even if you're having some assumptions, use that assumptions, write that assumptions down, and tell them like this is what we assume. Please correct, or if you think something else is there, just let us know so that the assumptions which you made will be correct and the approach which you follow will be in an effective manner. So that's the first step when you when dealing with an data analytics problem or database problem, any problem, even data engineering problem, because this all these things starts right from the data. And another important thing is with the development in technology, what is happening in the industry is that you might see streaming data. For example, you might be working for an textile industry, like for example, let's take Myntra or Flipkart or Amazon. So what happens is like you need to provide a recommendation engines to the customers. You might have seen like when you buy an shoe, there will be recommended products for you. I mean, even if you visit something, there will be recommended products for you. In order to do that one, there will be a lot of analysis that is going behind, and there is an algorithm that is running behind. So in order to do that one, you'll be continuously getting data. So you need to have a way, need to which will capture this continuously streaming data and then use that data to perform your analytics. So in order to create a pipeline, I mean, in order to deal with that one, you need to create a pipeline. Like you know how the data initially when you start working on that particular project, you know how the data is coming, what is the format of data, what is the information that is there in data, and you know you need to decide upon what are the transformations I need to apply so that this will be analytics ready. And then once what happens is like every data point that goes into pipeline, you will be writing some code in the pipeline is nothing but writing some code which will apply all the transformations that are required to perform on this particular data, and this will generate an resultant data which will be available for doing particular analytics beyond this particular pipeline. So the data that is coming out of this pipeline will be used for analytics. So even for this analytics, you already know what kind of analytics you need to do, what kind of plots you need to visualize, and what kind of calculated tables or what kind of calculated columns you need to create. So you need to create a pipeline for that one as well, so that you will be having final information. And by just selecting different features, you will be able to look at the plots or analyze different information about this product. And finally, this data can go into a recommendation algorithm, which will, based on the attributes and based on the features of different customers, it will generate what are the products that he can be recommended. That person can generally be preferred to. So this one thing, recommendation algorithms and recommendations are one thing which is currently trending and which are widely used in industry. So this is applicable to Netflix if you are using Netflix, Prime, Amazon Prime Video. So anywhere this something that works beyond this recommendation algorithm, and in recommendation algorithm will be using streaming data. And when you go to logistics sector, what happens is like you'll be continuously receiving streaming data about what will be the optimized route. So here you are not building any algorithm, but you are identifying what is the optimized route based on different attributes like what is the peak traffic time, what are the hurdles that you will face in this particular route map, and what are the what kind of check posts or what are the information that is available with you in the data in order to understand what will be the optimal route in order to move a particular vehicle from route A to route B. This kind of analytics is being done behind companies like Uber or any other logistics company which uses this kind of analytics to recommend you the best or optimized route. Because behind that, there are a lot of people who are working to do analytics and we are building algorithms and dealing with the data. These all are real-time data. And there's one more real-time data which is going to be trending in manufacturing sector, which is IoT analytics. Are you aware about this Internet of Things? Anyone aware about any manufacturing plant or manufacturing industry? Anything that will be manufactured? So you know, like there will be multiple reactors and there will be multiple process and you need to maintain some critical parameters in order to get the particular product out. So they are going to install these particular sensors and in that particular equipments and machines. I mean, this can, if you are not aware about this manufacturing industry, this is applicable to this particular, even for a vehicle also. Like for example, for the if there is a sound that is coming from a particular device, based on that change in frequency of that particular sound, you can predict whether that machine has to go through a maintenance schedule or not. So it depends on changes in frequency of that particular voice or what do you call that sound information that will be used to measure, understand the changes in the frequency of sound, which will be used to predict what can, I mean, is there any necessity for this particular maintenance schedule or not. So that's how these vehicles are being, I mean, vehicles are coming up with this IoT goods. And even if you, there in healthcare also, you might have, you are aware about these smartwatches and the smart devices, right? So there is an company which is working towards building and doing analytics to understand if a particular patient of a disease, there is a disease, I forgot the name of the disease. What happens is like in that disease, the particular patient will freeze down, and when he freezes down, they will fall down and they are hurting, and majority of patients with that disease are dying because of that reason. Because suddenly he will be walking like this and suddenly he will get freezes, suddenly he will get freezed and then he'll fall down, which will damage his head or which will cause previous injuries leading to death. So what these companies are doing is that they are trying to analyze his information from this smartwatch to predict what is the probability that this particular person will fall down at this point of time, what is the probability that this particular person will face the kind of freeze that will happen for this particular disease based on his biological parameters. So through that, it was, I mean, it's kind of breakthrough, and they were able to predict this kind of I mean, this kind of situations a bit earlier, which will, which was a bit by which they were able to call an emergency service to take care of that particular patient. So this, they are working this in USA. So right now it's in development stage. So this is one of the projects we heard while working. So these are our continuous data. I mean, like you'll be receiving data continuously, and you need to deal with data, and you need to perform analytics on top of this particular data. So coming to second type of data, you'll be having batch data. You'll be having an data sitting in your databases, and you need to take the data and perform analytics on top of that one, or create some calculated columns on top of that one, and then push that to stakeholders. I mean, like for example, you might be aware about Power BI, like building dashboards and updating these dashboards continuously. So these dashboards will be available with the CXOs, where they will be looking at these dashboards and making decision. Okay, this is the trend of sales. Okay, this is what is happening in my this is what is happening in my employer staff strength. So there is a lot of attrition data in this year. So was there any policy that made this decision? Or their sales that is, I mean, there's dip in sales. So what is the root cause behind that one? So you need to show them like what is there any other parameter which is correlating with this one, so that they can understand, okay, this is the reason why the sales are going downwards. Like for example, you might see their competitor product might have launched with a low price. There can be different things that can be done. So this is batch data where you already have data, and in case of batch data, what happens is like in most of the cases, the batch data, if you are working for a product organization, in most of the cases, the batch data will be dealt by a data engineer. So you can expect the data will be clean. So only thing is you need to perform the actions you wanted to do on top of that data, and then use that information to come up with your analytics and create the dashboards and push that to the CXOs who will be visualizing that information. So this is how the data will be. Major data is continuous data, and I mean, right now the major data is batch data, but currently there is a lot of momentum towards streaming data as well, with development of IoTs, and a lot of progresses are going on in that particular field. So yeah, that's about this kind of data. So any questions so far? Anything you'd like to know?
Does this AI tools affect our data analysis?
It depends. I mean, if you are able to, I mean, I don't confidently say that, I can't directly say that this will affect or this won't affect. But one thing I can tell you is like AI is going to be part of your job, for sure. You can't avoid that one. So you need to know how to utilize that for your benefit. So if you are okay, I mean, if you are ready to utilize that for your benefit, then you always will be ahead, and it will be actually, in fact, it will be more helpful for you without, I mean, see, for example, let's take an LLM. You are aware about a large language model, right? So what it does is, in backend, what it happens with that one is like it was trained on huge corpus of data, and it predicts what it predicts the probability of next sentence based on the information which your text we are passing through it. So it will be keeping on generating that next tokens based on the information that is available with it. And for this one, they use bidirectional encoding technique. So that what happens is like they will be using information from this end as well as this end, so that they can predict what is the probability of this particular word based if this is the information that is available with me. So you have an LLM with you, and how well you can eclipse. Earlier, what happens is like you might not be aware about. Are you aware about this Copilot?
Yes.
Copilot, Microsoft Copilot, which helps you in coding. So what happens is like earlier, it will take around 1 day for you to write an function or an operator or a method which you need to define in order to do some ETL operation on top of your data. But what happens now is that you can take help of Copilot, so that it will help you in it will reduce the time from 1 day to 1 hour, so that you will be more efficient. So it will help you in easily building that particular function. You know what is the logic. You want to in order to write that one, you might be first writing a step, and next writing a step, and you are testing that one, and then it will through an error, you will be working on debugging that one. But your Copilot will help you in doing that one fast, and it will improve your performance. So obviously, this AI is helping you. Simultaneously, for every function you write, you might need to write. I mean, there is a condition that you need to write a test case for that one. So in order to write a test case, it will take a lot of time for you. So it's I mean, you are wasting around 6 to 7 hours to write a test case for that one. So by using Copilot, what happens is like you already have a function which you wrote, and to write a test case, you can take help of this Copilot, which will help you in writing the test case faster. So what happens is like it will reduce the time you spend on writing this one and applying your logic on top of that one. It will save you a lot of hours. So you will become more efficient for the company. If you don't use Copilot again, someone else will be using that one, and you will not use that one, and you will be taking 6 hours to do the same work which other person is doing in 1 hour. So it's like this. I mean, if you utilize for your benefit, it will be helpful for you. Whether you accept it or not, you have to go with the flow. So AI is there for sure, and you have to work with AI in order to be in this competition. So you need to understand how AI works, and you need to know how it can utilize this for your benefit. This just one example, like Copilot is just one example. Even in analytics industry, you can use that to build dashboards. You can use that to, I mean, like you just, sorry?
Inside.
Yeah, you can derive insight. For example, you might not be, you are unable to understand what is going on with some information. But this particular, by feeding this information to the AI, it might tell you like you are looking from one dimension, it might be looking from another dimension. So it's like adding different perspective to the same information that's available with you. So what happens is like it will come up with different information, and it will provide you different insights to you. So that's how it will work. So my suggestion would be to understand how AI works, and to know how to get information from AI. So, and use that for your benefit. But be cautious. Never ever, please note this one very important. Never ever use any personalized data or any data that needs to be secured from the company, or any data that is related to company in AI without any authorized permission from your organization. Never use that information, because that information will be available for you. So never use your personal information. Never use any of your company's information when you are in an organization, because I can't give you a clear. I mean, I can't confidently tell you this, but there are some cases where I heard this. So I can't substantiate this one, but I heard this that Samsung designs were leaked out because of using that. So someone used that information to get information from AI, but that designs were leaked out. So this is one of the major issues. And when you are in healthcare, you'll be dealing with patients' data. And particularly if the company is genetic company, you'll be using patients' genetic data. which is very crucial, and you will be signing an data confidentiality agreement with any data company. So if you use this one, this genetic information of that particular patient will go out, and that genetic information can be used to do anything. So be sure, be careful while using AI. Never ever use company's data, confidential data, or your personal data. So this is my recommendation. So please follow that one. And when you are in a product organization, mostly they will be providing you an what do you call it, firewall protected AI service for you. They are providing that one. We confirm that from the team, and then only use that one. Okay. Any other questions?
How would you deal with the null values?
Null values, dealing null values is not that big problem right now, because you can fill them. Depends, like for example, go here. Okay, so let's take null values. So in I think in the data set which was given to you, there were null values in this one. Let me see. Yeah, if you look at this one, let me show you the data set first. So this is UAE auto sales data. Like they wanted to understand what is the information that can be derived from this information. Like I mean, what are the insights that can be derived from this particular information? So they have been storing this sales data from different manufacturers, because when they sell an vehicle to someone, that information will be registered in the registered location. So that information is collected, and they want to understand how the sales of different vehicles are being impacted, and what kind of price changes were observed over the period, and what kind of change in user preference was observed over the time period, and what are different insights that can be derived from this data set. If you look at this data set, there are multiple columns in this one, like this is the price, which is price of that particular vehicle, and the brand and the model. You have brand as well as model of that particular car, and this is trim, and number of kilometers. This is a used car data set. So this is the number of kilometers that driven by that particular car, and year of manufacture of vehicle, and vehicle age years, and regional specs, and number of doors, body type. Let me show you what are the total columns here. 27 columns are there. So apart from the doors, body type, we have fuel type like petrol, diesel or hybrid or electric. And what is the seating capacity, transmission type, engine capacity, horsepower, number of cylinders, exterior color, and location in latitude, longitude, because what is in which location the particular vehicle was sold to. So depending upon the location, also the price of vehicle changes. Right? Can you apply that one in India? Yes. How? Like for example, region is one of the factors that decides price of a vehicle, used vehicle. Can you give me an example in India, in case of India?
Used like
Come on. Delhi. In Delhi, the price of a vehicle is compared very less when you compare with the same vehicle in Hyderabad or in Bangalore. So a location has obviously impact on that particular sales of the particular vehicle, as well as the particular price of the particular model as well. So yeah, you're asking something. So if you look at this data set here, you have null columns in trim. I don't remember what the trim is, and you have null values in engine capacity. You have null values in horsepower. You have null values in area name, location name, latitude, and longitude. So here, let's see what is this trim is. What kind of data that trim has particularly. So it's a string type, and let me see how many values, what kind of values are there in that. So it's a string type, and based on this one, what happens is like there are around 823 different types of values. So my suggestion would be, so this is an one type of so this is one type of information which we need to deal with this one, because you can see the different types of values that are present in the trim column are other standard yes, yes, CG6, these are string characters. So this is an string type of information that is available in this particular column. And coming to this particular engine capacity, we know that engine capacity will be an numeric column, right? You all agree with this part? Engine capacity will be an numeric value, because every car will have an CC value for the particular vehicle. So you can use that. That should be a numeric column. But if you look at this particular data set, what kind of data is that? Okay. So it's not a string type here. Because the problem is, if you look at the data, I will let you go through the data and you'll be working on that one, right? So what happened is, here when they wrote this information, they gave a range of the CC, like 2000 to 2500 CC, 2600 to 2000, 3000 CC, 3000 CC to 3500 CC, 4000 plus, like that. So what happens is, like, out of, even though in spite of that column being an numerical column, the information that is available in the data frame is string object type, which defeats the purpose of applying any kind of transformation on that one. So I will come to that null values one, because if you understand this case, then that will be easy for you. So let's assume, like, let's assume that this is of engine capacity is of numeric data, and we need to perform some transformation in order to convert that into numeric data. So once you do that one, you will still be having the same number of nulls which you can see here. So you will be having around see, if you look at this one, you will be having 1961 null values here. So for 1961 rows, there are null values for this particular feature. So first, let's say you converted this into numerical value. And when you have a numerical value, one best thing which we can do in order to fill these null values is we can go with either mean or median. But when should we go with mean and when should we go with median? Anyone? We'll go with median, but why can't mean? Why can't we go with mean? It's perfect. Outliers. So what happens is, like, when you use mean, it will not take because of these outliers, this particular value will be shifted towards like, for example, the CC for most of the vehicles is 2000 CC, and there is one vehicle or two vehicles which has CC of 10,000 CC. Let's assume like this, not 1000, but just assume that there are 10 or 20 vehicles which are having of 10,000 CC. So what happens is, like, the mean value will shift to 5,000 to 6,000. So which is actually not the right way to approach for this particular problem statement. So that's why we use median from for this one. But my recommendation would be, you need to come up with some kind of correlation between, because this capacity will obviously depend upon horsepower. Do you agree with me? Yes. So what happens is, like, this particular column depends on this particular column. So you need to come up with, and you need to first find out, are there any null values? Are there any null values in engine capacity wherever there is data in horsepower on that? There is a possibility, because you have only 458 null values in horsepower, whereas 1961 null values in case of engine capacity. So if these two are correlated, we can come up with, we can segregate this engine capacity based on horsepower, and we can use the median value of that particular segment, right? You understand me? If you can create group by, like, for example, even you can create a group by through using model, brand name, and then horsepower, number of cylinders, because number of cylinders also indirectly affect engine capacity. So when you know this kind of information, you group by all this information into different groups, like, for example, on through horsepower, then through brand, through number of cylinders, through brand, and through model, and then use the median value rather than taking entire median value, because this approach will be will closely resemble the data rather than taking entire median of the entire data set. Any doubt here? Any question? Are you following me in this? Does that make sense to you? Like instead of using the median value, if we group by this information and use the median, what happens is like it will closely reflect the information because, for example, I know that there is some horsepower, some X horsepower, and in general for that X horsepower, the CC will be within the range of 1,000 to 2,000. But actually, the median value for entire data is 3,000. So that will not make any sense, right? But if you are boosting the horsepower and then using that median of that particular group, then what happens is like it will closely reflect the information and you are effectively dealing with the particular null values. So this one approach to use median for numerical data. But again, what I recommend is don't just go with the median value of that particular column. Try to find out relation with any other column and try to use grouped median rather than grouped median rather than using overall median of to fill that particular null values. So again, so generally you can use mean or median. If there are outliers, what happens is like the outliers will shift the mean. So that's why we don't recommend mean and we always go with median. And that too, by doing the group, by calculating group to median, will be better to use that filling as null value. And coming to categorical data like this one, you can see this particular trim will having different null value, and there are 813 different types of categorical variable, different types of categories within this particular column. So even in this case also, this function will be having some in relation with the brand of the model, or make of the model, or year of the model. So try to group by with different ones and use the mode of that particular category. Like you'll be using most frequent or most repeated value in order to fill the null values in case of categorical data. So what happens is like that will give us closest information that can be used to fill the data. If you have a lot of data and losing the data is not a big problem for you, you can go and drop null values, drop the rows where there are null values for the particular column. But I never recommend that one because every data point is important. Every data point will have some information that can be extracted from that. And if you see more than 80% of rows are nulls in particular column, I don't find any information that can be derived from the particular column. So I would go and drop that particular column. And at the same time, in a row, if out of 100 columns, if that particular row is having null values for around 80 or 90 columns, then I will for sure go and drop that because I don't find I don't find any positive information that can be derived from this particular information. So that's how you deal with null values. When you have null values, everyone will come up and tell like, okay, I will fill with median, I will fill with mode. But most of them don't try this approach to group by and try to derive what can be done in order to try. When our main goal is to find and write and close to ideal value for that particular data point using other information which is available. There are other ways as well. Like for example, you can try and come up with a value that can be used for this particular data point using KNN regressor. If you know this data science machine learning models, so there is an algorithm called K nearest neighbors, which can be used to find out what will be the ideal value for this null value based on other attributes of that particular data point. So use that information. So what happens is like you are indirectly predicting the value, provided that I have this information with me. So indirectly you are making the prediction which will be closest to the information that can be sometimes I forget. Whatever it is, if you understand, that's the right. Okay. So that will be the closest value you can use for that particular null value. So, and there is another algorithm as well which will help you in dealing with this one, which is random forest. So you can use random forest as well to come up with a right value for this particular null value. So there are different techniques. Like I mean, you can either go with median, group median, mean, most frequent word, most frequent mode values, and random forest algorithm are used machine learning because let's say here the price is. If you look at this data set, generally the price will be the predictive variable where you need to build an algorithm to predict price. But when you have null values, use engine capacity as your target variable and try to predict that one using this information. Because these both are related. By default, we know that these all are interrelated. So we can come up with some solution. We can fill that information first and then use the data to train the model. So that's how you can do your analytics and you can come up with null values. But a caution, always tell your approach to stakeholder. This is what I mean. If you are in a company, most of they will be product owner who will be dealing with that particular project. So he will be contacting with the customer if you are working for a service company. So you approach the product owner. He will tell him like, this is what I am assuming, this is what I am thinking, this is what my approach would be. So do you approve this one or not? So if they approve, you can go ahead. Any questions? Anyone, any questions? So that's how we deal with one of the major problem null values. Another problem is you will be like, let's take, for example, this will be, I mean, for analytics, this is not a problem. But for building models, having categorical data is one of the major problems because computers can't understand categorical data. So for that one, you need to first convert them into numerical data. So to do that one, you'll be using encoding techniques. So you'll be coming up with either label encoding or not encoding. In label encoding, what you will do is you will assign values for all the different categories. For example, if I take this trim value here, I have 813 different types of categories in that particular column. So if I do label encoding, what happens is like it will add 813 values from 0 to 813. So it will give 0 to other, 1 to standard, 2 to S, 3 to SC, and that information will be used. So, and when we do one-hot encoding, what happens is like in one-hot encoding, you are creating 813 columns. So there will be 813 columns, like one column will be for other, one column will be for standard, one column will be for S. And if that particular other is present, there will be 1. And if that column is not, that particular data point is not present, there will be 0 for it. So that's how you differentiate, you create this categorical data into numeric data to in order to train the models. I don't think that will be useful for you, but just for your information. So another thing is, main thing is you need to understand group by. So Panda provides an group by function. Even SQL provides you with group by function. Yeah, group by and order by will also be there. So both the Pandas and SQL both use this group by and order by. And when you go into analytics industry, you will be using this particular group by and order by very frequently. So we try to experiment with this group by and order by functions in Pandas as well as SQL. Right now, I don't think you're having access to SQL database, right? So try to use group by in Pandas and try to do different analytics on top of this particular data set so that you will understand how well this group by will help you in understanding that information, how well you can derive information from this one. And there is another way that you can use, I mean, you have latitude and longitude. So another thing, important thing is like you need to come up with impelling visualizations. So that should be more attractive. I mean, everyone would like to have an attractive visualizations with them. So and that particularly when they are C exposed, they don't be focusing on all this coding and what we are doing in the backend. What they want, they like is they like to look at compelling visualization which will serve the purpose. So for that one, you might need to add different functionalities, like you need to add filters which will allow them to filter across different. Like for example, if they want to know what is the price range for a car with 1,000 cc capacity, so you need to have a filter with ranges of engine capacity and brand models and model of the car and year of manufacture. So you need to give filters along with that one. And you can also use Google Maps mapping. I mean, you can also use maps also in order to show visualization about how prices are varying across different regions and what are the models that are demanded in different regions, so that you can understand where to focus what and where to keep what. For example, if you know that, for example, in a particular location, people will like to have only premium cars. It's worthless to take all the cars to Delhi where people only buy premium cars. So you can move all these non-premium cars to different locations and keep only premium cars so that the logistics cost will be handled effectively. Because if someone from Bangalore or someone from Rajasthan want to buy non-premium car, and if it's in Delhi, you need to transport that one from there to here. So better to keep at the buying location by understanding the analytics. You will be able to understand. You will be able to deliver better insights to them. So there are multiple ways to come up with dashboards, and there is no right way and there is no wrong way, and there are no limitations to generate visualizations or dashboards. So it's all about how we think. We need to understand. So if I am an consumer or if I am an user, what will I expect? So what would I like to look at? So for that one, you need to understand how things work in that particular segment. So that's why you get the initial meetings with stakeholders where you need to ask the questions, and that will be the most important meeting which you will be having with the stakeholder, and that will decide the path of your analytics project which you are going to deal with. So always ask the right questions, always have the right questions, be prepared, get the questions, because you won't get the luxury to ask multiple questions, same question multiple times. So you need to deliver the project as soon as possible. So come up with the right, first understand the data, use that information to generate insights from that particular data. And in order to generate the right insights, you need to have right understanding of the stakeholder or the right understanding of the user as well. So understand the user, understand the data, come up with right dashboards and right set of dashboards or analytics or insights that you can deliver to a particular. Any questions? Do you want me to solve this problem and then show you, or you will be solving this problem? You will be solving, right? So look at the data. So because I was working on this data and yesterday, and I found there are a lot of interesting facts within this data, and you can even come up with. So there was just to give you an hint, there are the price variations based on place of that particular vehicle, and over the time there are changes in price, and over the time there was change in user preference. So there are different insights and interesting insights that are available within this data, and but trust me that you will face some trouble while dealing with this data, because there are different actions and transformations you need to apply on top of this data in order to make it readily available. My recommendation will be try to create pipelines, try to automate this one, and if you have your workspace, try to work in Visual Studio or PyCharm. Work on Jupyter Notebook to understand that one, but try to create pipelines in PyCharm or Visual Studio so that you can feed the data set directly to that one, which should perform all these transformations and finally generate the result. So this will, rather than just don't focus just on running it in Jupyter Notebook and then using the deriving, making the plots and all, and showing that information. But if you can do this in a pipeline, this is what industry standard is, doing it in pipelines. So try that. Do it in Visual Studio or PyCharm. Initially, you might feel some difficulty, but trust me, it will be better. It will be more easy to use PyCharm and Visual Studio than Jupyter Notebook. When you understand that one, you will feel more comfortable working with that too rather than this one. And another thing I wanted to tell you is, like, you try to use Plotly. There is a library called Plotly, which will provide you interactive plots. So try to use Plotly and come up with insights using that Plotly. So where you can provide dragging bars, you can provide drop downs, because that's how you generate insights from that one. And if you already have Power BI, try to generate insights in Power BI by connecting this information in separate location. So you come up with the calculated tables, calculated procedures, and different steps in Power BI, and showcase that in your LinkedIn profiles, which will help you in coming up with like showcasing your talent over there. And another thing I always recommend is be active in GitHub. People will actually look at your GitHub and what you are doing, whether you are active or not. Keep pushing codes to GitHub, and you will always be using GitHub for sure. When you go to any industry, you will be using GitHub, because they will be using CI/CD pipelines. every company is shifting towards agile work space. So when they are trying to become agile, so there will be CI/CD pipelines, and you will be using GitHub for sure. So try to. That's why I'm telling you to practice in Python and Visual Studio Code. So be aware with that one, and it's not difficult. It's easy. Once you start practicing, it will become easy. And GitHub is also easy only. Try to, rather than going and directly uploading GitHub, try to use the commands that are available for GitHub, like git commit, git add, git push, git stage, git stash. Different, there are um, different commands that are available to work in GitHub. So when you work in an industry, you'll be using command operations only. So try to use commands rather than manual operation. So if you are good at all these things, then it will be easy for you to enter into industry. Any questions? Anything you want me to explain? Anything?
What field did you start with and what fields you were in?
I started with the specialty chemicals industry, which was into water treatment. So the company primarily was into providing specialty chemicals to avoid corrosion, scaling, and if you are aware about the terms, you might be aware about corrosion because you might see rust on steel. So and the scaling also you will be aware because your taps will be forming some scale within that one after some years. Even the buckets will have that white patches. So that's the scaling they deal with, and corrosion and biological activity in water treatment systems. So for that one, we had systems installed in different water. This is for industrial systems. So systems installed for different industrial water treatment systems, which will take water samples and measure the process parameter and sends data by using a SIM card which is pasted in that location within that system which we provide to them. And that data will be sent to our database for every 6 seconds. So that the data will be coming to our database and sitting for every 6 seconds, and data will be available. So we have multiple threshold values which will trigger an alarm when that particular parameter reaches that particular value. So we try to identify what can happen. I mean, when once it triggers that alarm, so we will be receiving an alert to us. So we will take that particular plant's data and then use that data, try to find out which parameters are pushing this particular parameter towards this alarm level, and why is this particular alarm triggering, because why is this parameter reaching this level. What are the conditions that are making it to reach that level by correlating it with different process parameters and coming up with solution for that one and recommending to that one. So we are ideally predicting what can happen with this one and what can happen to the plant if this continues like this, and what is the root cause behind this one by using data. So we used to come up with different correlation plots between these process parameters and try to identify what was the root cause. So that was my first role. And then I worked with an energy service company to provide services to power plants and refineries. And then I moved into the renewable energy sector, then later into pharma, where we try to predict what can be estimated waste that will be generated given when these conditions of manufacturing activity, and what will be the inventory level that are required based on the demand for the particular drug. For example, if you are manufacturing some drug, let's say paracetamol. So to manufacture paracetamol, you will be needing some raw materials. So you first estimate what is the demand for this particular paracetamol drug by using demand forecasting. And once you know what is the demand for this particular drug, you know what is the real consumption of raw materials that are required in order to manufacture this particular drug, that is that particular drug, that is paracetamol. But theoretically, you know that this is the mix. I mean, this is the quantity mix that I need to mix in order to provide this particular drug. But in reality, there will be loss salary, right? In reality, for example, if you need 3 kgs of some X drug and 4 kgs of Y drug in order to produce 6 kgs of some Z drug, In reality, what happens is like you'll be really using 3.5 kgs of X and 4.5 kgs of X because there will be losses while handling or while manufacturing or while failing of batches. And there are different factors which will contribute to us. So when you know the demand, you will try to go into backend and you will try to predict what will be the required amount of raw material X, raw material Y in order to manufacture X amount of this particular drug by using previous batch parameters. So use that one and then make predictions about this. So that's one thing. And at the same time, we try to predict the wastage of generation of waste based on production parameter. And then I provide, as I told, I worked with an insurance project where we try to predict what is the probability that particular customer will turn into business. And if he turns into business, what is the probability of particular product across the 4 products? He will be interested. Like we are not predicting whether he will turn into business or not. We are trying to predict probability. If you remember last week regression will come with the probability of prediction only. So we use the probability and we use the threshold to come up with the yes or no. But here, what we wanted to know is we want to know the probability. So that in the next level, we can use this probability along with the interest of that particular consumers interest towards this particular product. There are 4 products, and among what is the probability for each product that this customer will buy. So we are using these 2 probabilities to come up with what is the time we need to spend on this particular customer. What is the resources we need to spend on this customer. So if we spend this resource on this particular customer, is that worth it? Will that be an best decision based on the information we have? So, like for example, there is this another interesting case I worked on. So, not this one, the previous one. So we have, that advertising, right? So advertising will be different ways. It can be social media, it can be TV, it can be audio, it can be direct advertising, it can be pamphlets. There will be different mediums of advertising. There is a company which which did surveys and which collected information about different segments of people and different segments of products they use and different types of mediums through which they started purchasing that particular product. So what happens is like we have data, and if we want to take that information and we want to use the information which is available with this company to come up with an prediction purchasing pattern of a user belonging to this demography and this region based on the information that is available in survey. So what ideally we are doing is like what is the right advertisement we need to focus upon. Like if you have 1 crore rupee of budget for advertising, where to focus more so as to generate more sales. So based on this advertising information, based on purchasing pattern of people, we try to understand what kind of advertising will be good for this category of product and this category of demographic profile of a person. So that what happens is like the budget can be divided into different advertising segment, and budget allocation will be done based on this one. This is one thing we worked on, and the instance one, and the other one was genetic data, like to predict a particular disease of a particular patient, provided genetic data and demographic data. So we get samples from that, and we build an algorithm to predict if that particular person will face this particular disease in future or not, based on a genetic and this data. And if you belong to that particular disease, there are approved medicines for, there's some list of approved medicines. Which medicine will be more, give more results, provided that this is the genetic data of the patient and provided that he belongs to this particular class of disease. And once we build this algorithm also, we try to analyze what will be the chance that this particular patient will face adverse events. You know that adverse events, right? When you take a drug, they might be facing some side effects, right? We call it side effects. So what is the chance that this particular person will face side effect? And across the list of side effects, what is the probability that he faces any particular side effect? So this was the multi-level problem. So we dealt with this one. So yeah, we asked about with generative AI as well, like fine-tuning large language models. And you might have heard about this retrieval augmented generation RAG frequently you are seeing in blogs or in LinkedIn posts. You see this RAG architecture, which is question answer system. Like you give you a document and you ask some question to that one, it will generate response based on the document. So we worked on the RAG as well using large language models, and fine tuning large language models for that particular use case, and querying a data frame based on large language model give data frame access to the language model and fine tune that one based on this data so that that will respond to the questions based on the data frame. And also another interesting work I did was one of the computer vision problem where we want to use transfer learning because there was already a trained model by Google, which was known as ResNet. I mean, there are multiple, even Microsoft model is also there, multiple pre-trained models. So what they do is like they take a lot of images. If you remember, people used to get paid by uploading images and tagging the images. If you all remember, you might have tagged your photos, tagged your images in Facebook, and I hope everyone might have done this. Snapchats and all this information will be used to, I mean, you tag there, this is me, this so and so, I don't know, some, let's say this X person, this X1 person, this X2 person. So what we do is like that data was taken and they try to create a trained model so that the trained model will be able to understand the edges and patterns of different facial features of persons and different patterns of different objects within the world. And we use the trained model to add multiple layers on top of that one so that that will work for our purpose. In our case, we had to identify the model of a brand car, given an image of the car, which either partially damaged or fully damaged or partial image of that car. So we used, we didn't have the image data, so we had to download from Car24 or something, and we had only 60 images. So we applied this transfer learning technique and then trained the model. And when we gave 70% damage in accident car, it was able to identify the model quickly, even though the model name was not there and the car was damaged 70%, only partial car was available. So even still, it was able to predict the car model with the 95% accuracy, and the model accuracy was also 94%. So yeah, that's another problem statement I wrote down, and that's mostly. And there are other projects as well. Most of them in POC is like that. Any other question? Yeah. Can you do any examples where you it depends on the problem statement. I mean, you need to either use, you might, for example, let's say you have price and you are using only one variable to see how this particular price is being impacted by this particular target feature variable. Then, or else you might sometimes come up and think, okay, let me use two features and see how these two features are interacting together, and at the same time, how these two features together are impacting the target variable. So this is how it depends on you will always be applying univariate, bivariate, multivariate analysis in any of your problem statement. Yeah, I mean, sometimes only univariate is sufficient enough because the correlation between them is that kind of correlation. If you don't find correlation, you don't do, but you will start doing analysis using multiple features and different features and single features as well. But the problem is that if you don't find any useful insight that can be derived by using multivariate analysis, then you can just directly go with univariate. But always you'll be doing both. Depends on your problem and it depends on the insights you can derive from. Yeah.
So you started to make this data, so data scientist.
That time it was not, there's no data scientist or data analyst like that. So it was in budding this, so my delivery was technically easier at that time. And as we were dealing with water treatment data, it was like mostly industrial segment. But we were sitting in some corporate office like this, and we were getting data, and we should perform analytics on top of this. So we can consider it as analytics because time I didn't use any standard data frames or I didn't use SQL to train the models and that. We mostly use Excel. I mean, that time we used only Excel. We try to come up with Excel. We use VLOOKUP and try to create multi-parameter plots, and then we utilized what different features of Excel at the time.
But might be a situation like this, right? Whatever you studied was different, and when you're coming to the real-time world and when you're working, that is different. So how did you
So
say
you're asking like you might study some different subject and what you are working will be different, right? What do you think is happening in India?
No, that's not the thing actually.
Let me tell you one thing. I am chemical engineer. I don't know whether anyone knows chemical engineering or not. My background is chemical engineering, and what I'm doing is obviously, but if you ask me, it's kind of correlated because the first thing I worked was industrial water treatment systems. Some process parameter, I need to have idea about the process parameters, and my chemical engineering will help me that. At the same time, I went for civil services. So I know different economic and geographical patterns based on my knowledge from civil service. So I use that one here when I was working with, because in my civil service, my option was anthropology. So there I had to learn about genetics. That helped me a lot in dealing with the genetic problem statement which I was, because genetics is, I mean, I personally feel, because there were a lot of people who were working on the same thing, but they were unable to understand what is chromosome, what is this one, what is gene, what is that one, what is these things. But I know that because I already had to go through that struggle while I was preparing for my exam. So yeah, that helped me. Here in this particular analytics and data industry, even if you are from different background, for sure, I agree with you. We are not doing what we study. That's for sure. I know, I agree with your point, and that's what is happening in India. That's why they are. If you look at 2000s, from 2000 to 2010, the major degrees at the time was civil engineering, electrical engineering, electronics engineering, and all these degrees, mechanical engineering. Sorry, if there are any mechanical engineers, I forgot, but that's one of the premium engineering at that time. But most of them, most of that 2000 to 2002 were in technical, and they are building applications using Java. So how is Java related to mechanical or civil or electrical? So it's like that. I mean, even what is your background?
I'm an MBA HR. I'm BBA finance.
Okay, you might be applying whatever you did in, let's say, civil engineers. Yeah, they might also apply in real life, but they don't apply all the concepts, right? I mean, someone will be in highway engineering, someone will be in buildings. So it's like that. I mean, whatever the option we have, we'll go into that. So for me, my engineering helped me in different cases, like in the pharmaceutical segment, which I mentioned in the industrial water treatment system. That helped me because you need to have an idea about what is happening behind that, which feature I need to select, why should I select that? So it will help me in that case. So if a mechanical engineer there, while he's dealing with some automobile data set, while he's dealing with, let's say, the sound one, which I told you, they are trying to predict what will be the maintenance, whether if a particular vehicle is ready for maintenance or not. You can use that audio data to, in order to understand, to build a model or to understand this analytics. So in that case, his subject will be more useful for it, because it's how things work. And even computer vision is being used to identify if a particular product manufactured is defect or not. This case was applied in an airline industry, where they passed all the parts they manufactured through an computer vision algorithm, which tried to, which was even able to understand even minute crack within that one based on audio data and visualization data, and based on different vibrations that can be processed by using different frequencies. So that's, so in that case, and mechanical engineering will be of handy, because we know how things work. We don't know how these frequencies work. Differently, yeah, and even if you MBA also, you know how sales work, or you know how finance works. So while dealing with risk analytics, you know, like, okay, this can actually happen. If you are working in a bank and you're working for risk analytics, you know, like, okay, this is the thing I need to focus upon, this is the thing I need to focus upon. Or if you are building and generative AI algorithms, you need to know where which data I need to focus upon. So what is that that particular name I need to become in order to make these things happen. So your knowledge is never waste. So it will be useful, in particularly in data industry. But whether it comes to handy or not depends on the work. But for sure, I agree with your statement. We never do what we studied. Anything else? To be frank, it's tough, for sure. Not easy to get into, because they will, I mean, the problem is not that only about skills. The problem is getting into that field, making yourself showcase to them is important. So, for example, there is a company in India recently. If you are aware or not, majority of companies from US and Europe are shifting their hubs. I don't say shifting. They are starting their hubs in data, particularly in data hub in India. That too in Hyderabad. If you remember, for me, I know that BMS, Musul Whiz, has started their office in India. They are planning to recruit 2,500 people in India itself, in Hyderabad itself. So they are recruiting for freshers also. If you ask me, are there opportunities? Yes, there are lot number of opportunities for freshers as well. And even FedEx, how many of you are aware about FedEx services? Courier service. They are also opening their hub in India, in Hyderabad, and there are large organizations which are trying to open their hubs in India, knowing that there's a good talent here, and there are opportunities. I don't say there are no opportunities, but there are good number of opportunities. Only problem is the reason why I'm saying tough is that you need to showcase yourself. There is competition as well, and in fact, let me tell you, my company is looking for 5 years experience data scientist, but they are unable to find. But there are a lot of 5 years experience data scientists, but still they are unable to find. The problem is the gap between the requirement and the people. There is a gap between making these two people meet. So you need to identify the right companies. You need to be aware about where these opportunities are. You need to always be ready to apply, and you need to always be ready to apply your skills. And that's why I always ask you to be active in LinkedIn and in GitHub so that you will understand what is going on, what they're expecting. And that's why I tell you, like, we have some width in the data industry as well, so that when there is an competition between you and some other person who knows other things as well, they will prefer him more than you. So that's one thing. So you need to be fast enough. You need to be active. You need to try ready. You need to be ready to grab the opportunity whenever it shows up. So you should not waste time delaying applying. Keep on applying. Keep on. LinkedIn is a good option. Naukri is also a good option. Maybe you don't get calls initially, but if you continuously try, I can assure you that you will for sure get a job. So there's, of course, the problem is the recruiters are unable to find the right people. They don't know where the people are, and these people don't know where the openings are. There is a gap. So you need to. They will not ready to come and approach you because they will go to some consultancy and they will get that work done. But you need it. So you need to try and fill that, and you need to go towards that. And you need to show them that I'm here and I'm ready and I'm available and I can do the job. Don't say it's easy. If I say it's easy, then you will be like, you will ignore and you will become quite lazy. So better, I can say that it's tough for a fresher. It will be tough, not just in data industry. Even if you are Java professional, trust me that Java is one of the most one of the most demanded role, full stack Java. But still, full stack Java freshers are finding it difficult to find a job because no one will be ready to train a guy by taking them into job, and then they need to spend 2 months not 2 months, they need to spend 1 year to train him, and that's what the opinion is. But you need to prove it wrong. You need to prove it wrong by telling him by showcasing that you don't need to train me on everything. Just you show me the opportunity, I will be able to do that. You just guide me, I will do. That's what you need to. Anything else? Anyone?
What is cloud analytics?
Are you aware about AWS, GCP, Azure? So even Oracle and Alibaba also will be there. So if you are doing in your server, in your base, then you will be doing a local analytics. But if you are doing in cloud service, you are using cloud services like AWS provides some different services for storing data, for data engineering, for analytics, and for building training models, and for even generative AI as well. So if you are doing that analytics in cloud based services, then it's cloud analytics. And always learn at least one cloud based code. Be aware about at least one of the cloud service. either AWS or Azure or GCP. So be aware of that one, and it will be helpful for you. Because majority of companies are turning towards cloud to scale up and scale down the operations. It will be added advantage for sure. It will be added advantage because most of the companies are moving towards it. Only the secured and important things will be kept in the database. Rest of them will be moved because it's about the scaling up and scaling down. Do you understand scaling up and scaling down? So let's take what is the Amazon sale? Comes frequently. Big billion. Yes. Big billion.
Amazon creating,
Flipkart Big Billion,
creating,
right? So let's take Flipkart Big Billion sale. So generally, let's say Flipkart gets a user base of around 10,000 per day. So your servers and your processing speeds and everything will be in order to meet 1,000 customers per day. So that will be your physical servers and physical capacity that is available. Physical capacity that will be available with you. You will be maintaining that one because on an average at any point of day you will be having 10,000 visitors to your website. So you need to handle that amount of traffic with you. But when you start sales, what happens is like your number of visitors will shot up to 1 lakh to 2 lakhs. So what happens is like your servers will come down and the entire thing will go down, and you lose trust from the customer. So in order to reach that kind of changes in user base, what happens is like you need to scale up immediately because what happens is like there is another concept called microservices. So everything, like for example, if you are in Flipkart, the web page that we visit, the home page will be in one microservice, in one in form of one code, and there will be another service where you provide recommendations, and there will be one other microservice which will be applicable for building, like you select, you add to the cart, and there will be another application for just only to process the payment you do with that for the goods you purchased from that particular store. So these all these different microservices are indirectly, directly connected to each other, but they are different. Like for example, if there is issue with payment module only, payment microservice only, rest of the service will be working effectively, and there will be nothing that will impact this entire process. And you need to work on only this payment microservice only. So that what happens is like you'll add to the cart and you will start making payment, and it fails. If this entire architecture is single architecture, what happens is like entire service will go, and whatever you added will go away from your cart, and you need to start from the scratch again. So in order to avoid this one, they came up with this microservice architecture. So even this payment microservices fails, you will still be able to see your goods in your cart, and you don't need to spend other time on that. So you will be ready to, again, once it restarts, you will be ready to go ahead and make the payment. Similarly, so when you have these different microservices, what happens is like you don't need to increase the capacity of all these microservices to 1 lakh, because most of the people will be visiting only the home page. And if they are satisfied, then will add the products to their category. So you just need to scale up this particular home page only, so that it should accommodate 1 lakh people at any point of time. So you will just only increase this capacity, this particular microservices capacity, so that you will save a lot of money within that one. And as soon as number of users increase, an extra processing capacity will be requested from the cloud service provider, and automatically it will scale up. So it will be ready to increase, it will be ready to handle increased number of customers. So when the number of customers declines, automatically it will scale down and the resource will be empty, and you will not be charged for using for that particular resources. So that's how the scaling up and scaling down will work, and microservices will work. So that is what is trending in industry, and that's what they are doing. Because earlier, what happens is like you're building entire application in a single case, and whenever something goes wrong, entire application will be done. But here, the entire application will be divided into different microservices, and if something goes wrong in some microservices, and there will be backup for each microservice. That's where you come up with this containers and Kubernetes architecture. And my recommendation is try to understand how these containers and Kubernetes work. It will help you a lot, and also understand microservices that will be helpful for you. So what happens is like when one part goes down, second part will be ready, and it will provide the services. But even though it will not be able to accommodate all the 1 lakh people, but all the 1 lakh are not coming to this particular place. So that's how the scaling up and scaling down will be done. And that's how this microservice is helping building applications. Anyone else? Here, everyone?
Yeah. We use the gradient. There will be more of the same value.
Yeah, that's why we come again.
We use the gradient. There will be same value, the same value will be added to the blocks. So, instead of using that, if we use forward fill or backward fill,
We can do that one. But how the forward fill and backward fill work in such a way that it will be based upon the previous row that is available or the next row that is available. But we can't assume that the next row or the previous row will have the attributes that are required to fill that particular value, right? You can apply that one if you know the data effectively and if you know that forward fill will work effectively. But like for example, if you are reading a continuous data and the next column and the feature data will be dependent upon this previous data point and it's a continuous data, then you can try the forward fill and backward fill because you generally know that the next value will always be filled from this particular data. Let's say time series data. So any sales data that is happening from this particular fund 13, that data will be dependent upon 12. So you can use that forward filling over there. So it depends upon the type of data you are dealing. Any other questions? So this is the data set. Go through that, and I will share the notebook which I worked on. I think it might be helpful for you. I'll share it to you. So go through that, and if you find it helpful, it will be better. And as I told you, don't just try to generate insights from this particular Jupyter notebook itself. Do that one if it's your assignment, but try to create a pipeline for that one and try to do that in VS Studio Code or PyCharm and try to upload that to GitHub and try to connect with that GitHub and make changes here and try to see how that GitHub is working and try to connect this data with your Power BI and work around that one as well and showcase all this information in your LinkedIn and your GitHub so that will increase your chance of getting it out. Yeah. So best of luck. Thank you.
Yeah, you can find this data set in your dashboard. Okay. Go to dashboard, and in dashboard there is schedule block. Okay, left side. You recently? Yeah, I will explain later. Yeah, so in your dashboard, here you have schedule block. Okay, so go to schedule block. Here you can see the hackathon name. Okay, open this, and right side you can see. Here you have total questions and description about the data set. And next you have resources. Here you can download the data set. Okay, download the data set and go through with the data set. Later on, upload your file here. Complete this project in Python or Excel or Power BI. Any module you can choose to do EDA. Fine, you can choose any module and you can complete this project and later on upload your IPYNB file or XLSX file or PBX file. Fine. Yeah. Any doubts as of now in this?
No doubts.